Your voice is lagging, sir.
Good morning, sir.
Yes, please mute everyone. Please mute. Okay. So last class we were discussing about the concept of moment. Please mute everyone. So we have seen that moment is the tendency of force to make a rigid body to rotate about an axis, and we have seen what is moment axis. Here in this figure, OO is the moment axis. Moment center is the A point. This A point is the moment center, and this from this force, the perpendicular distance from moment center to the line of action of the force is called moment arm, right? So this we have seen, and we have also seen how to compute the amount of moment, that is force into distance, perpendicular distance, that we have seen. And also we have seen that clockwise moment is negative and anti-clockwise moment is positive, and we have also seen that for a particular body, if you have a force acting on that, and your four fingers are actually um, representing the moment directions. So at the point of the thumb, which way it is actually directing is the true sense of moment. Okay, so if the rotation is indicated by the four fingers, then the which way the thumb is actually pointing, that is your true sense of moment. Now if it is anti-clockwise, then thumb will be pointing upward, and if it is clockwise, that is negative, then it will be pointing downward. Okay, and now we have also seen that line of action and moment arm, and we have found out. So this is the question last time I asked you. So I think you must have tried. Let's see whether you are right or not. In this question, let's go through again. The example is saying that a 100 Newton vertical force is applied to the end of a lever at A, okay, which is attached to a shaft at O as shown in the figure. Okay, now there are multiple questions you have to answer. The first is the moment about 100 a moment of 100 Newton force about O. This is very simple. How to find out the moment? This is the force and perpendicular distance we have to find out, and if we multiply, we'll get the moment. Okay, the next is magnitude of the horizontal force applied at A which develops the same moment. So it is asking that there, you forget about this force, there will be another force applied in the horizontal direction, in this horizontal direction, which will create the same moment. Now from the first question we got the moment value. Now we will consider a force acting in the horizontal direction. We know the perpendicular distance, so this force into perpendicular distance will be that moment. Then from that equation we can find out the horizontal force. Now another question is the smallest force at A which develops the same effect about O. So there will be multiple, there are infinite number of direction in which way that this force can act. Okay, this 100 Newton force can act. Here in this question a force is given, it is acting vertically downward and its value is 100 Newton. Now it is asking that if this force can act any direction, so where this force will act, that will be creating the same effect, but the value of force will be minimum considering all the direction. Okay, that is one question. So you have to you know that moment is equal to perpendicular distance into the force. Okay, now if moment is, you know, the moment value is constant. Okay, here let's say that is, you know, now moment is equal to force into distance. Now when the force will be maximum, when the distance, when the force will be minimum, when the distance uh, from that force to that point will be maximum. So when the distance will be maximum, force will be minimum. So in this case, when the distance will be maximum, when that force is perpendicular to that line, so then the perpendicular distance will be to, hello, then the perpendicular distance will be 240 mm. In other any direction, if you consider the perpendicular direction, you have to consider certain component of 240 mm which will be less than 240 mm. So if this force acting perpendicular to this AO line, that distance will be maximum, and then the force which is acting perpendicular to OA line will be the minimum force. So we have to find out that way. Another is how far from the shaft a 240 Newton vertical force must act to develop the same effect. So we know the amount of moment here. Now let's say there is another force vertically downward, 240 Newton force is there. So let's say from this point O, we are considering that from D distance this 240 kilonewton force is applied. Okay, now we know the total moment. So 240 Newton force acting downward from D distance here. So 240 Newton into the perpendicular distance of D is equal to the total moment we have calculated. If we equate that to, we can find out the value of the distance from O, where we can, where 240 Newton force is applied. But you have to consider the component here. Okay, let's see. Let's one by one we will solve. Okay.
Sir, can you explain about that second bit, sir, again?
Magnitude of the horizontal force. Acha, let me solve this, then it will be clear. First question is the moment of 100 Newton force about O. Okay, so moment of 100 Newton force means here to 100 Newton force is applied. So what will be the moment? That force into perpendicular distance. So here the force is applied vertically downward. So this distance, this is 90 degrees. So this distance will be perpendicular distance. Now this is 240 mm and this angle is 60 degrees. So what will be the value of D here? The value of D will be 240 cos 60. So that will be the perpendicular distance. Now what will be the moment? Moment will be F into D. So that is 240 kilonewton, 240 millimeter into cos 60 is coming 120 mm. That is the value of D. Moment about O is F into D, that is 100 Newton into 120 millimeter. So 12,000 Newton millimeter clockwise moment is generating.
Sir,
Tell me.
please minimize the screen.
Minimize?
The slide.
Why?
Sir, before 240 cos 60 degree, it is not visible. That's why.
I'm
Sir,
not
it's
getting.
clear.
If I minimize, what will happen?
There is nothing before
Sir,
240 cos 60.
Sir, it is not clear, sir.
Please
Sir,
tell
he's
me
saying
clearly what is, what? Left side you cannot see.
sir.
No, sir.
For
Not visual.
Are you getting the problem? Can you solve it?
Yes, sir.
yes, sir.
Bas,
Yes, sir.
that is what important. Okay, the here the force into perpendicular distance is your moment. There is nothing difficult here. Just force into perpendicular distance. 240 cos 60 into F. F is 100, so 100 into 120, that is 12,000 Newton millimeter. Okay, clock, and this is direction is clockwise, so this is negative moment. Simple.
Yes, sir.
Now
Yes, sir.
let's go to the second question. Magnitude magnitude of the horizontal force applied at A which develops same moment about O. So we will consider one force like this F, which is acting in the horizontal direction. Now it is asking you to find out the value of F as it is acting horizontally. So what will be the value of F considering the same effect? Same effect means we have already calculated the moment. So we will take that moment and we have to find out this. F is acting horizontally, perpendicular distance will be, so you have to take this line of action of F and you have to find out this distance. Okay, so that will, if this was your cos 60, so this will be your sin 60, that vertical distance. So D will be 240 sin 60, so that is 207.85 mm, that will be the vertical distance. Okay, I mean perpendicular distance with the with respect to this horizontal force. Okay, now what will be the moment? Moment will be force into this perpendicular distance, so that is F into 240 sin 60, that value will be equal to the moment we have already calculated, that is 12,000 Newton millimeter. So if you equate this to F into 207.85 is equal to 12,000 Newton millimeter. So F is coming 12,000 by 7.85, that is 57.73 Newton. Is it clear?
Yes, sir.
Yes, sir.
Okay,
Yes, sir.
fine.
Yes, sir.
The simplest problem. Now the question is, what is the smallest force at A which develops the same effect? Now as I said that uh, in this A point there will be this F can act in multiple directions. Okay, but here depending upon the direction, if this distance is 240 mm, so this F will change to create the same effect at O point. Now as I said that F M equal to F into D, say equal to moment by distance. Now moment is your constant. To make F is minimum, D has to be maximum. Okay, D has to be maximum. Now when the D will be maximum, if this D distance, D this 240 mm, this whole 240 mm is act as the momentum. So when it will act as momentum, when this F will act perpendicular to this AO axis. Okay, so force is smallest when the perpendicular distance is maximum, so to produce so as to produce the same moment. Okay, maximum distance between AO point O and the point A is 240 mm. Okay, if you take any other distance force is acting, then you have to take the component, horizontal or vertical distance, that you have to take to find out the perpendicular moment. So maximum perpendicular distance from F point to this O, that will be 240 mm. So F is equal to M by D. So F, you have to find the minimum F. So M already you have known, that is 12,000 Newton millimeter, and D if it is maximum, that value will be 240 mm. So 12,000 by 240 mm, that is coming 50 Newton. Okay, so this is the minimum force which will, if it is acting perpendicular to AO line, then it will create the same effect. Is it clear?
Yes, sir.
Okay. Now
Yes, sir.
now the fourth question. The fourth question, it is asking how far from the shaft a 240 Newton vertical force must act to develop the same effect. Okay. Now it is asking that, let's say, please mute. Uh, So in this question, let's say that 240 Newton force is applied anywhere in the middle of OA, which is d distance away from the from this moment center O. Okay. Now, what, let's say this is 240 Newton force and the distance is d. So what will be the moment? The moment will be d cos theta, because that will be the perpendicular distance. So d cos theta into this 240 Newton. Okay. So 240 Newton into d cos theta will be 12,000. So from there actually you can find out the value of d. Or here what it is doing, the distance along x-axis, let's consider x. So m is already 12,000 by 240 mm, that is 50 mm. It is, you are getting that this x value is 50 mm. So distance along the shaft will be x d cos theta, or d will be x by cos theta, that is 60 degrees. So 50 by cos 60, that is 100 mm. So this value is 50 mm. So you have to find out this direction, what is the value of d, that is coming 100 mm. Okay. Or you can, by seeing the geometry, you can directly say that d cos theta into 240 will be your 12,000 Newton millimeter. So from there you can get d to millimeter. That is the answer for this question. So how far from the shaft a 240 Newton vertical force must act to develop the same effect? The answer is 100 millimeter from the point O. Is it clear?
Yes, sir.
Yes,
Okay.
sir.
Yes, sir.
Fine.
Yes, sir.
Fine.
Yes, sir.
So this is how you have to solve. This is one question which is actually for the understanding of how moment is calculated. Okay. Now there is something to understand, that is called Varignan's theorem. Okay. What it says, that moment of a force at any point is equal to the sum of the moment of the component of the force at the same point. It is not, it is very easy. It is nothing but, let's say if you have a 80 Newton force, a person is pulling at range with 80 Newton force, but it is in at 60 degree. Okay. Now how to find out the moment? We just did a few minutes back, that we have to find out the perpendicular distance with this point, because this is inclined. So we have to along the line of action, and then we have to find out the perpendicular distance, and that force into that perpendicular distance will give you the force. Instead of doing that, we can actually divide this force into two components. We have done that, how to find out the component or Cartesian component or rectangular component into two mutually perpendicular direction. We know that 80 Newton force is there. It can be divided into two forces like Fx and Fy. Okay. Now this theorem is saying that if you do the if you calculate the moment by using the perpendicular distance from the moment center to the line of action of the force, it will be equal to the moment, if you calculate the moment using the component of the force. Like in this case, 80 into the perpendicular distance from this point will be equal to the sum of the moment generated by this component force Fy and Fx. But here, what will be the force generated by, what will be the moment generated by the force Fx and Fy? Can anyone tell me what will be the, first tell me what will be the moment generated by this force Fx?
0.
Sir, Apex is
Zero.
moment.
Zero.
No.
Zero,
Zero.
because the line of action is
Zero,
passing
sir.
through this
Sir,
moment
0.
center. Okay.
Yes,
The
sir.
Fx, so line of action is passing through this moment center, so that will be 0. What will be the moment developed by this Fy force? That will be
480 root 3.
Fy
480.
into
36.
480 root 3.
480 root
okay.
3.
Root 12.
Okay. and this 12 centimeter is the perpendicular distance, so that will be this, and this will be anti-clockwise, so positive. Okay, so that is what it is saying. Okay, so let's see that two components are 69.3 Newton and 40 Newton. I hope this is right, and then you can find out the moment. Rx equal to 0, Ry is equal to 12 centimeter. So moment about O will be 69.3 into 0.12 meter. So that will be the total moment 8.1 Newton meter as before. Okay. So if you calculate this, if you calculate from the inclined force and if you calculate with the component force, it will be coming same. Okay. Now there is the statement is saying that the moment of a force about a point about a moment center or axis is equal to the algebraic sum of the moment of its component forces about the same moment center. That is what we have discussed so far. Okay, so here let's say A is the moment center, and if you have a force acting P which is theta angle with the horizontal axis, so if you can find out the moment developed by this force P and the perpendicular distance is g, so the moment will be P into d. Okay, moment will be P into d, and if you take the component of this P force with this horizontal angle, that is P cos theta and P sin theta you will get, and the perpendicular distance if you consider d1 and d2 for P cos theta and P sin theta or horizontal and vertical axis. So this will be P into d will be equal to P cos theta into d1 plus P sin theta into d2. So moment of a force P about the point A will be equal to algebraic sum of the moment of the component of the moments of the components of the force P about the point A. This is Varignan's theorem, and there is a small proof how to prove that whether this moment developed by the resultant force will be equal to the algebraic sum of the moment developed by its component. So let's see, this is very easy. Okay. So let's R be the given force. Okay, and the component, you see the P and Q are the component of R. P and Q are the component of R, but this time we are not taking rectangular component, it can be any component. Okay, oblique component. So that generalize, you can see that, let's say this is R, and in this P and Q direction the component of R is P and Q. Okay, now we have to prove that the moment generated by R will be equal to the sum of moment generated by P and Q. So that we have to prove. Okay, now alpha, beta or gamma, the inclination of P, R and Q with respect to this x-axis. So alpha, this angle, beta and gamma, these are the three angles with the horizontal axis that we are considering, and this small p, small q and small r are the perpendicular distance from this O point to all these forces. Okay, O point is here. Now if you see let's say this is your x-axis and this is your y-axis. So for all the forces, if you know the angle alpha, beta and gamma, so you can actually divide this into two components. P cos alpha will be the horizontal component and P sin alpha will be the vertical component of the force P, and that is we are using the symbol Py for the vertical component. Similarly, Qy and Ry we can calculate, which are the vertical component of PQR forces respectively, right? So we have already discussed how to find out the resultant force. There we have done that summation of y component, summation of Fy will be equal to the sum of all the y component of the forces. So here we can write y component of the resultant force Ry will be equal to y component of P force plus y component of Q force. Okay, so Ry will be equal to Py plus Qy. Okay, now Ry we can calculate, this is R force and the angle with the horizontal axis is beta, so R sin beta will be Ry. Similarly, P sin alpha and Q sin gamma will be the vertical component of P and Q force respectively. So from this triangle, you see, from this triangle AOB, from this triangle AOB, if you want to find out what will be the sin alpha, that will be this small p by AO, perpendicular by this AO line. Okay, so P by AO will be sin alpha. Similarly, R by AO will be sin beta and Q by AO will be sin gamma. So if you put the value of sin alpha, sin beta and sin gamma in equation number 1, then you can get R into small r divided by AO is equal to P into small p divided by AO plus Q into
মোবাইল বন্ধ করে দিচ্ছ হ্যাঁ
See, I am taking a class. You should be serious about whether your mic is off or not. If you continuously keep talking with your family members and the sound is coming, it is quite disturbing. So I cannot concentrate on the class. So you should be little bit careful. Okay. So what we are discussing is the summation of vertical component of the resultant force will be equal to the sum of vertical component of all other forces. So R into, as I said, from this triangle we can find out the value of sin alpha, sin beta and sin gamma. If you put the values in this equation number 1, you will get that this AO will be common to everything, then AO you can cancel out. So ultimately you will get capital R into small r, that means the force R with the perpendicular distance small r will be equal to force P into small p is the perpendicular distance from P to horizontal axis, and force Q into small q. Okay, so from this expression R into small r, P into small p and Q into small q, from this expression we can say that moment of resultant R about O is equal to the algebraic sum of the moment of the component force P and Q. So sometimes if you are asked to prove Varignan's theorem, so you have to just simply write this. It is nothing but you have to consider a vertical, you have to consider a mutually perpendicular axis x and y, and you have to take a resultant force whose components are P and Q in any direction it can be, and you have to take the perpendicular distance from any point of the horizontal axis for all the three forces like P, Q and R, and you will know the angle alpha, beta and gamma, and you have to take the vertical component and equate it with the vertical component of others, and you can easily come to this conclusion. So that is the proof of this. Now let's say in a particular system, if there are multiple, so this theorem is clear to everyone?
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
Yes, sir.
Fine, fine.
Yes, sir.
yes sir
Okay, so now we have to see that in this type of problem where multiple forces are acting, how to find out the resultant moment. So we have also found out the resultant force, okay, in earlier classes. So now our task is to find out resultant moment. Okay, in this system you can see in this system we can see that there are number of forces acting, and we have to find out the moment. Here 20 kilonewton force is acting, 40 kilonewton, sorry, not kilonewton, 20 newton, 40 newton and 30 newton, and they are acting in different position and in different direction. Okay, the geometry is given, and this is very easy, but you have to be careful about the signs. Okay, so let's say first we are trying to taking small steps to understand how to find out the resultant moment. So please be with me, and step by step we will understand this. Okay, so let's say first we consider this 20 Newton force. This 20 Newton force, you see this angle is 30 degree, and this bar is 4 meter. So we have to find out the perpendicular distance. That will be, this side will be cos theta, this side will be sin theta. So 4 meter into sin 30, that is 2 meter. So 20 kilonewton is acting at from A, and the perpendicular distance is 2 meters. So what will be the moment? It will be 20 into 2, and the direction you can understand, the direction will be clockwise, as this way the force is acting, this way the force is acting, and this is your perpendicular direction. So rotation will be clockwise rotation. So this is negative, right? So this will be the rotation, and this moment is negative. So that is 20 kilonewton, 20 Newton force. Next, so minus 40 Newton meter is the moment developed by 20 Newton force. That is one thing. Next, we will go for this second force of 30 Newton. It is acting 30 degree with the horizontal. So you see this bar is 6 meter, this portion of the bar is 2 meter, so total is 8 meter, and this angle is 30 degree. So we have to find out the perpendicular distance. What will be the perpendicular distance? So this is 30 degree, so this value will be cos theta, this will be sin theta. So 8 sin theta sin 30 will be the value of r here. So that is coming 4 meter. Now 30 Newton into 4 meter, you see about O we are calculating the moment. So this is the direction, and this is the perpendicular distance. So this is the rotation. Okay, this is the rotation which is clockwise. So that means it is negative. And what is the value? That is 30 into 4, that is 120 Newton meter, and it is clockwise. So this is negative moment, Newton meter, minus 120 Newton meter. So two forces are done. There is one more force, that is 40 Newton, which is acting vertically downward. Okay, now as this is acting vertically downward and we are calculating the moment about A, so the perpendicular distance will be the distance mentioned here, that is 2 meter. So what will be the moment here? You see 40 into 2 will be the moment, right? 40 into 2. And what will be the direction of the moment? That is, you see this is the force and this is the moment center. So it will be creating anti-clockwise rotation, anti-clockwise or counter-clockwise rotation. So we can say this moment is positive. Okay, understood? Now we have calculated moment using three forces. So what will be the resultant moment? That will be nothing but the summation of all three moments. So resultant moment is sum of all individual moments, but along with the sign. So M20, M30 and M40. So M20 is for the moment for 20 Newton force, M30 is the moment for 30 Newton force, and M40 is the moment for 40 Newton force. First point is clockwise, first moment is clockwise, so negative. Second was also clockwise, so negative, and third one is anti-clockwise, that is positive. So minus 40 Newton meter, minus 120 Newton meter, plus 80 Newton meter. If you just add these three, you will get minus 80 Newton meter. So resultant moment is minus 80 Newton meter, or you can say 80 Newton meter clockwise moment. So that's how you have to find out the resultant moment, right? let's solve one more. I think this is very simple and it is easy to understand. So we'll see one more question.
Yes, sir.
Okay. So determine the resultant moment of the four forces acting on the rod about point O. So like you see this figure, there are multiple forces acting on this particular object and you have to find about this O point. Okay. Ritik Kumar, are you listening to my class? Ritik Kumar. Hello.
Yes, sir.
Okay, Ritik, in
Yes.
this figure, can you see the figure? Can you see the slide?
No, sir. Slides are not coming now. Yes,
Huh?
sir. Now I'm seeing, sir.
Okay, tell me if you understood now how to calculate the moment.
Yes, sir.
So tell me what will be the moment about O for this 20 Newton force.
20. We have to take component of this 3 meter, that is 3 sine 30, and now we have to multiply with 20 Newton.
And the moment will be
20 multiplied by 3 sine 30.
whether it is positive or negative.
It is positive.
Okay.
Sir, anti-clockwise. Sir, anti-clockwise होगा.
Who? What is
Dubey.
Rohit Dubey? Tell me. Ritik, you mute your mic. Rohit Dubey, tell me what is the moment of
Sir, I
this
cannot
60,
able to see the picture. Now you
this
can
six-
see this.
this 60 Newton force? What will be the moment?
So there will be zero moment about point O.
Fine. You mute your mic. Okay.
Thank you, sir.
Let's ask one more guy. Premalata Patel. Are you listening to my class? Hello. Premalata. No. Pratik Mishra. Pratik Mishra.
Yes, sir.
Okay. Pratik. So you tell me what will be the moment for this 40 Newton force? 40 Newton. Can you see 40 Newton?
Yes, sir.
Tell me.
40 into 2 plus 2, 4 meter, and then the component of 3 meter force, that is 3 cos 30
3 cos 30 and the moment
plus
will
4
be
meter. 40 into 4 plus 3 cos 30.
sign of moment.
Positive. Sorry, negative.
Negative moment. Okay. Fine. So some of you are not, I think you have all understood how to calculate moment as I have asked randomly. But, if you are just being online and not listening to the class, that will not work. Okay, I can ask randomly.
Sir, for the 50 Newton force?
Sir, what is for the 50 Newton force?
Tell me,
100.
Yes,
you
sir.
tell me, who is talking? What's your name? What will be the moment for 50 Newton force?
100.
100.
50 into
100
2.
positive or negative?
Minus 100.
Negative.
Clockwise.
Minus
Negative.
100.
Negative.
It
Clockwise.
is
Negative.
clockwise or
Minus
negative?
negative.
Negative.
Okay,
Negative.
okay, fine.
100%
Fine.
negative.
Okay,
Negative.
so that's how you have to calculate the as some of you are asking, so this is 50 Newton force and this is applied 2 meter away from this moment center, and this is the perpendicular distance, so the moment will be 50 into 2 and it is actually the rotation is clockwise, so that will be the negative moment, okay, clockwise moment. So if you see the answer, what will be the resultant moment at point O, okay, so that will be minus 50 into 2, that is for this 50 Newton, that or for 60 the moment term is passing through this moment center, so that is 0. Perpendicular distance is 0, so 60 n into 0, and also this 20 Newton force, which is the vertical distance, will be 3 sine 30. So 3 sine 30 plus 20, that is actually anti-clockwise, so that is positive. And this 40 Newton force, this is actually clockwise, and that value will be, as someone rightly said, 4 meter plus 3 cos 30. Okay, so that if you just do the summation of all these forces, you will get minus 334 Newton meter or 334 Newton meter clockwise moment. Are you getting the same answer if some of you are calculating?
Yes, sir.
Yes, sir.
334.
Yes, sir.
Yes,
Yes,
sir.
sir.
Yes, sir.
Okay. Now, now you will be introduced to a concept called couple that we have to. Tell me.
Sir, what about the 20 Newton force?
You are not listening or what?
No, sir, the 20 Newton force was only calculated for the 3 meter. It was not for the O point also. That's why I'm asking.
What is the perpendicular distance from O to 20 Newton force?
Yes, sir.
What is the
That's
distance?
not
Tell me.
0.
0.
What is the perpendicular distance from the line
3
of
by 2.
action of 20
3
meter?
sine
degree.
3 sine
20
30.
Newton.
Sin 30.
So 3
Yes, 3
sine
sine
3 sine 30.
3 sin 30.
So 3 sine
3
30, what
sine
I
30, sir.
told you, you have to take the line of action like this, and this distance you have to calculate. This distance will be equal to this distance. So this is 3 meter, this will be 3 cos 30 and this will be 3 sine 30. So 3 sine 30 is the perpendicular distance from O point to the line of action of 20 Newton force. Are you getting it?
Yes, sir. Got that.
Okay, fine. But this is you have to calculate the moment for each forces and then you have to add it. Okay.
Okay.
Now we will discuss about first actually think, don't jump into the question, first actually think whether you can solve it or not, then you ask. Otherwise, almost 180 students there are, I see almost 191 students are in this class, but only 182 have actually joined. So if you have any contact with other student, I don't know, you don't know each other, you have never met, but still if anyone is contacting you, then you can share the code of this team, and then they can join. There are few students left, I think. Okay. And also uh, I ask you to form a, let's say, a group, maybe in WhatsApp, in your if I have to pass any information, then I will tell any one of you or I will assign some person who will forming the group. Hello?
Yes, we have, sir.
You have already created
Yes, sir.
So we have
Yes, sir.
already made a WhatsApp group.
for
So
this
your
class.
number,
So
Sir,
for
yeah.
this class,
No, sir.
so
No,
For
I
sir.
so
will
please
For,
add.
for this,
for
we will
all the
add.
courses.
No, we can create another group for physics.
sir, for physics, sir, we
For,
have not created a special group, sir.
This is not physics class.
sorry, mechanics.
Yeah, mechanics. हुई।
Sir, we will create a group.
So for this particular A section, actually A section students are attending my class. You can form a group, and then if I have to or individual doubts, you can ask in the chat box. But very, fast thing to and try to solve that. These are very basic things, huh? This is very easy. If
Yes.
you just give 5 minutes, and you will be easily getting the answer by yourself, and that in that way it is more fun, huh? Because you are solving your own problem. Anyway, I am always there if you have any problem. So let's see. We'll now discuss about the uh, this term called couple. Okay, two parallel non-collinear. So parallel means they are not, they will never meet. Okay, non-collinear, that means they are not in a single line. Collinear force, I have told you, separated by a certain distance. Like here, F is a, and there is another force of the same magnitude but in opposite direction. There are two forces which are separated by a distance d. Okay, that are equal in magnitude and opposite in direction form. So what is couple? Let's say if you have a force like this, and there is another force which is acting d distance from the initial force, which has same magnitude but in opposite direction. So the algebraic summation of these two forces forming couple is 0. So here, if you consider this is positive and this will be negative, so the summation of forces will be G. The effect of force, the effect of force will form a couple. Couple means is similar to the moment. That means if you have a, let's say if you have a bar here, you apply force here, you apply force here, so that bar will rotate with this particular center. Okay, so hence the couple does not produce any translation. So here, if we apply the force like this, two equal forces opposite in direction, they will never produce any translation in the body. So that body will not linearly move here and there, but that body will rotate due to application of these two forces which are equal in magnitude, opposite in direction, and separated by a distance d. Okay, so the value of the couple will be here is F into d, that is moment. Okay, let's say if you want to go into the details, resolution of force into a force couple system. First, let's say AB is a bar and there is a force acting F, F force is acting at A. So replace the force acting at point A to B, apply two equal and opposite forces of the same magnitude and the direction as force F at point B, so that the external effect is unchanged. So let's say if you have a force like this, so we will apply a force like this here, but this force, if we have to balance this force, we will apply a force here. So if you combine these two force, what will be the net effect at B point due to addition of these two equal and opposite force at the same point? That will be 0. So there will be no external effect. Okay, but if you consider this type of forces, let's say initially there is some force and you have added these two equally opposite force at B point. So if we remove now this force and this force, as I discussed earlier, that this force is acting this way, and this force has the same magnitude but acting opposite way, opposite direction, and separated by d. So this force and this force are actually these two opposite and equal magnitude force separated by a distance is forming a couple, and value of the couple will be or moment value of the couple will be F into D, as I said. So in this force system, you see initially there is this force. I have added these two forces because these two forces are cancelling each other, so we can apply these two forces at B. But with this force and the initial force, they are actually forming a couple. So if I replace these two force with a moment or whose value will be F into D, as I discussed. So ultimately this will be equivalent to a force and a moment. So initially there was a force at point A. If I want to take that force A point to B point, what is happening? We can take that force here, but additional moment is coming. So initially there was a force at A, now there is a force, same force at B, but from A point to B point, as the force there is a additional moment of F into D is coming. So if we want to shift a force from A point to B point, then you can shift that force, but will be adding to that particular point. So of these three forces, two forces, that is one at A and other oppositely directed at B, form a couple. Moment of this couple is M equal to F into D. Like in the definition of couple, as I said, if there are two forces which are acting in the opposite direction and magnitude are the same and their perpendicular distance is D, then they will form a couple, and the moment of that couple will be F into D. So here initially there was a force, we have added two more forces, and initial force and the added force in the opposite direction form a couple, and ultimately a force along with this couple. Okay, so along this the moment of this particular couple, and the third force B is acting in the same direction that at A. So initially if there is one force, if you have to shift that force from one point to another, that force and the direction will remain same, plus additionally there will be a moment coming. Okay, thus the force acting at point A, such as acting at a point such as A in a rigid body, can be moved to any other given point B by adding a couple moment M. Okay, adding a couple M. The moment of the couple is equal to the moment of the in its original position about B. So ultimately what I am trying to say, let's say if you have a force acting at A, there is no other force initially, like in this figure. If there is a force acting at A in a particular direction, if we have to move that particular force from A point to B point, so the direction and magnitude of the force will remain same at B point, with there will be one addition of moment, the whose value will be the moment of this initial force with respect to the new point. So that moment the value will be F into perpendicular distance of the point we are taking moment to that line of action of the initial force. Like here D is the perpendicular distance. So ultimately if we want to move a force from A point to B, so there will be this force plus there will be a couple moment. Okay, M there will be, and its value will be F into D. Okay, now now there are different types of loads that we have to discuss, like concentrated load, uniformly distributed load, and uniformly varying load. This thing we will discuss in the next class. Okay, we'll start it. We'll take it forward from here in the next class. Before that, you
Okay,
just
sir.
wait.
Thank
Before
you,
that,
sir.
you just